Imagine something smaller than an atom, so tiny no microscope could ever see it, slipping silently into Earth's atmosphere. A microscopic black hole. No warning, no fireball, no explosion, just an invisible speck with the mass of a mountain and the gravity of a nightmare. At first, nothing unusual happens. A black hole this small emits no light, no heat, no sound. It simply falls through the sky like a ghost, passing through clouds, air molecules, and dust without slowing down. But while it's invisible, the space around it begins to twist. As it descends, atoms start behaving strangely. Electrons shift off their normal paths. Particles flicker and jitter. Air pressure fluctuates unpredictably. Weather balloons and satellites record impossible data. Microbursts of gravity so small and fast, they look like glitches. No one realizes what's actually happening. Not yet. When the black hole reaches lower altitudes, it begins pulling in matter. Not whole buildings or cars, but molecules, atoms, tiny pieces of reality. The effect is microscopic but intense. The black hole leaves behind a thin, ionized trail, a scar of disrupted atmosphere. Lightning-like discharges appear in clear skies. Birds alter their flight paths. GPS signals distort for milliseconds. Then the first real event strikes. A small area, no bigger than a coin, suddenly vanishes from a rock cliff deep in a remote region. Not broken, not cracked. Just gone. The black hole passes through the stone, as if it were smoke, snatching a few atoms on its way. The hole in the rock is so tiny no one notices, but with each atom consumed, the black hole grows, slowly, dangerously. Now it reaches the ground. It slips into Earth's crust like a bullet through water, passing through soil, minerals, and ancient layers of bedrock. Seismographs detect a bizarre microquake that lasts less than a second. Instruments trigger alarms, anomalies too small to classify but too strange to ignore. Deep underground, the black hole begins its real work. As it consumes atoms one by one, it gains mass, milligram by milligram. But with more mass comes stronger gravity. Its path through Earth becomes more destructive. Tunnels collapse. Pockets of gas implode. Subterranean chambers cave in, creating strange sinkholes on the surface. People across the world wake up to news of inexplicable circular holes appearing overnight. Within hours, scientists realize the terrifying truth. This is not geological activity. It's a gravitational object moving through the planet. If the black hole continues to grow even slowly, eventually it will begin to attract more than single atoms. Dust, pebbles, grains of sand, and then kilograms of matter. The process accelerates exponentially. Worst case scenario, the black hole settles in Earth's core, feeding endlessly on surrounding material. Over years or decades, it could hollow out the planet from the inside, shrinking Earth into a super-dense sphere of collapsing matter. Humanity wouldn't even know until the final years. But there is another possibility, one scientists hope for desperately. If the microscopic black hole was created by a high-energy cosmic event, it may be unstable. Some theoretical black holes evaporate rapidly through Hawking radiation. If this one is the unstable type, it could burn itself out before consuming even a gram of Earth. In that case, it dies suddenly, vanishing in a burst smaller than a spark. No explosion, no danger, just gone. And Earth survives without ever knowing how close it came to being eaten from the inside. This scenario reminds us of a terrifying cosmic truth. Space is full of objects we cannot see, cannot detect, cannot stop. And sometimes the deadliest things are not the biggest, but the smallest,